Hi there everyone, this is Ms. Page and this lesson is going to begin our Unit 13. In Unit 13 we are going to focus on the graphs of polynomial functions and behavior, zeros, real zeros, rational and irrational, things like that. Alright, and in this lesson we are going to introduce a concept that we call multiplicity. Multiplicity is when a function has more than one of the same zero. So like for example here we see the real zeros of this function and notice that 1 is listed twice. So we would say that the 0 of 1 has a multiplicity of 2. That little x there is generally read as the word of, meaning that there are 2 of them. Here we see that out of these real zeros, -5 is listed 3 times. So we would say -5 has a multiplicity of 3. Over here, we see that all of the real zeros are different. So here there would be no multiplicity. So what we have to understand is how multiplicity affects the graph of a polynomial function. So if our multiplicity is even multiplicity, then what it will do is create either a relative minimum or a relative maximum at that 0. So here we see we have even multiplicity like 2. 2 is an even number. So that would be like this situation here. And at the 0 of 1, we see that there is a relative maximum. Now, whether it will be a relative maximum or relative minimum is actually dependent upon the end behavior, which we would also need to know information about before we could determine whether it would be a relative minimum or a relative maximum. Here, odd multiplicity that is greater than 1 creates a point of inflection at the 0. So that would be like this one, where we have multiplicity of 3. 3 is an odd number. So at -5 here, we have this odd multiplicity, and that creates a point of inflection. We talked about points of inflection, and that what they do is at that point, the function changes its concavity. It changes from concave up to concave down or vice versa. So this one is going from concave up, and then it changes to concave down after that 0. All right, so in this lesson, we are going to be focusing on using multiplicity to create graphs of polynomial functions. So we're going to graph a polynomial function. We will be given the real zeros and we'll be given the end behavior because we'll need to know that too. So we'll graph points at the zeros and we'll want to make sure that we make a note of any 0 where there is multiplicity. So we keep track that that's where something special is going to happen. We will need to mark the quadrants where our end behavior or our function's end behavior is going to occur. So like, is it going to go up to positive infinity in quadrant 1 or quadrant 2? Is it going to be going to negative infinity in quadrant 3 and or quadrant 4? So if you don't remember your quadrants, this is quadrant 1 and then it goes counterclockwise. So quadrant 2, quadrant 3, quadrant 4. All right, once we've identified all of that, then what we will do is draw a nice smooth curve that includes the zeros, and we're going to have to estimate any relative maximums or minimums between zeros. If we go back here to this, notice that going from 0 to 0, the function here has to do either a relative maximum like it does there, or from this 0 to that 0, it has a relative minimum. We're going to have to estimate those. The only way we can actually determine what those are is with some calculus that we have not learned yet. All right, so let's take a look at this first example. So the given information, and fill in any information in your notes that was left off, which I think has to do with your real zeros here. So here's the information about our real zeros. And then this is the information about our end behavior. So I want to make sure everybody knows how to interpret the real zeros information correctly. So what we're looking at here is understanding that this multiplicity of 2 goes with the 0 it directly follows, and that is the 0 of 4. All right, so that is the 0 that has multiplicity. So our zeros in this case are 1, 4, and 4 again. All right. Okay, so we are going to draw our axes, and we want to make sure, of course, we draw our axes in such a way that we can graph these zeros. So I am going to put my y-axis right around here. Let's see if I can get it actually on that line. That's proving a little difficult. We'll go with that. And then usually your x-axis you can just put in the middle, since we are going to be estimating any points above or below the x-axis anyways. We will be using scales of 1 unit for both axes. No reason to do anything else since we are estimating. And so no numbers on our y-axis. If you want to put numbers on your x-axis, of course you can, but you should not put any numbers on your y-axis since we are estimating all those y values. All right, so I'm going to put a point at 1, which is one of my zeros. I'll try to anyways here. And I'm going to put a point here at my 0, 4. And I'm going to make a little mark to myself and to remind myself that here is where I have multiplicity at my 0 of 4. So I just like to generally make a little star. All right, well, the tech, I like stars, but my tech is having a little bit of difficulty here, so I'm going to do a little check mark right here to remind me that that's where something special happens. So now I'm going to pay attention to my end behavior. So here is my left end as x goes to negative infinity. So remember that would be over here. So I have to figure out, is on this end over here, is my function heading to positive or negative infinity? That being positive, that being negative. And this says it's heading to positive infinity. So this is where that left end is going to end up on this side. It's going to head up. And then on the right side, which is x going to positive infinity, my function says my function values are going to negative infinity, which means it's heading down over here on that right end. So now what I do is either starting from the left or from the right, whichever you find easiest to do. And here I'm actually just going to not even draw anything yet. So what's happening if I start up here is it's going to hit this 0, and then it's going to go straight through that 0 because that's a regular old 0. Then it has to turn around, and I got to turn it around over here somewhere because this 0 of 4 is going to have a relative maximum. And I know it's a relative maximum now because I'm coming up from below it. And I've got to make sure that it is nice and rounded right there. And that 0 is at the top of that little mound part. So I like to draw those mounds in first. And then from there, I will continue with everything else to create my graph. So I trace, figure out what's going to happen at my special zeros where there's multiplicity. And then I draw in the rest of the curve. Let's look at another example. All right, so here for this one, we have got these real zeros. So we have a real 0 of the negative square root of 39, which we're going to have to approximate without a calculator. We have done this before, but we'll go over it again. This multiplicity of 2 refers to only the 0 of negative 4. And then we also have a 0 of 0. So all of our zeros, we have our negative square root of 39. We have negative 4 twice, and we have 0. So let's talk about estimating our square root of negative 39. So we talked about how what we want to do is figure out what two perfect squares 39 is between. So you can even actually just look at, so if you're looking at the negative, you're looking kind of at a backwards. So here what we're looking at is 36 is a perfect square, and this is going to be negative 6. And then negative square root of 49, that's going to be our negative 7. So that's telling me that the negative square root of 39 is going to be between negative 6 and negative 7. Then remember what we did is we looked at the differences between the radicands. So 39 minus 36 is 3, and 49 minus 39 is 10. So 39 is a lot closer to 36, which means that the square root of 39, or the negative square root of 39, is a lot closer to negative 6. So it is probably right around somewhere about negative 6.2, negative 6.3, somewhere in there. So that's what we'll have to use for an approximation for that particular zero. All right, and so now what we're looking at is making sure that we can graph our negative 4 and our negative 6.3. So I'm going to push my y-axis way over here. X-axis again, I'm just going to leave in the middle. Remember, we're using a scale of 1 unit for x. And so now I'm going to put some points here for my zeros. So I've got this negative 6.3, which would be right about there. I have this negative 4, which has my multiplicity. So I'm going to make a little check mark there to remind myself. And then 0, which is my origin. So now I'm going to take a look at my end behavior here. So for the left end, what I'm looking at is as x goes to negative infinity, so that's over here, my function values go to negative infinity. My y's go to negative infinity. So that means the left end is going to be here in quadrant 3. And then the right end, what I'm looking at is as x goes to positive infinity over here on the right end, the function values, the y values, are again going to negative infinity. So it's over here in quadrant 4. All right, so now I'm going to draw in, or I'm going to figure out what my curve looks like. So I'm starting here, and it's going to come up. It's going to go through this 0 because it's just a regular old 0. It's going to turn around pretty quickly because here I have multiplicity. So it's going to come down at it from above, which means this is going to be a relative minimum, like so. And then it's going to continue, and it's going to have to turn around again to get to that 0 at 0, and then it's going to continue on like that. So I'm going to continue connecting and drawing everything, put my arrows on the end, and there is a sketch of this polynomial function. All right, I think the next is a practice. Let's see if I'm right about that. Yep. So for this practice, I want you to pause the video, sketch a graph of this using the information here, and then start the video again so you can check your graph. All right, let's take a look and see what our graph should look like. So here, what we see is we have zeros at negative 2, 0, and then our 3, which has our multiplicity. And our end behavior is to positive infinity on both ends. So that's our left end and our right end. So notice it goes straight through each of these zeros because they're just regular old zeros. But at 3, which has the multiplicity of 2 and even multiplicity, it creates a relative minimum. And then it heads to its other end behavior. Let's try another one. Pause your video here and graph this one. All right, let's take a look at this result. So here on this one, we have to estimate the square root of 30. And square root of 30 would be between square root of 25 and square root of 36, which are 5 and 6. And the difference between 30 and 25 is 5, and the difference between 36 and 30 is 6. So that makes it pretty close to the middle. So a good estimate would be 5.4 or 5.5. Either one which should be good enough. Here our multiplicity of 2 goes with our 0 of negative 1. And our end behavior goes to negative infinity over here on the left. positive on the right. So as it comes up, this has multiplicity, so it's going to have to create, coming up from below it, it has to create a relative maximum. And then the other one is just a regular old 0. And that then creates the graph, or a sketch of the graph anyways, as best we can do here. All right, and I do think there is another example here. So let's take a look at this one. All right, so for this one, we're now looking at our real zeros. We've got double multiplicity. So each of our zeros has multiplicity, and then we've got our end behavior here. So we've got -5 twice, regular, don't have to do it, and then our square root of 11 is twice. We have to estimate our square root of 11. So square root of 11 would be between the square root of 9 and the square root of 16. Square root of 9 is 3, square root of 16 is 4. 11 minus 9 is 2, and 16 minus 11 is 5. So that makes the square root of 11 closer to the square root of 9, which is 3. So probably about, say, 3.2. Let's go with that. All right, so I'm going to make my graph. So I need to get to 3.2 and also -5. So I want to make sure, but I'm just going to put my y-axis here in the middle. And then again, might as well keep the x-axis in the middle. No real reason to change it anywhere else in these particular problems. So we're looking at graphing our -5, 0, which has, not really what I was going for there. Let's change that color to something we can see. There we go. And that has multiplicity. So I want to remember that. It's my little check mark, sorry. And then 3.2. So here's 3, 3.2 would be right around in there. And it also has multiplicity. For my end behavior, what I see is on both ends, my function is going to positive infinity. So that means on the left end, it's going to be here, and on the right end, it's going to be up here. So it's going to come down, and then it's coming at this 0 from above, and that 0 has multiplicity, so it is going to be creating a relative minimum. Then it's going to have to turn around at some point and head towards this one, and it's going to come at this one from above too, so that's also going to be a relative minimum. And then I can kind of connect and draw everything else and put my arrows on the ends, and I've got a little sketch of the function. All right, let's take a look at this one. So here we have to realize there are no zeros with any multiplicity. And then we have our end behavior here. So I don't have to estimate anything. They're all rational zeros, no multiplicity to worry about. So I just want to make sure I draw my axes so I can get all these points on my x-axis. So at -3, we have a 0. And at +1, and at +6. So my end behavior, as x goes to -infinity, which would be on my left end, the function values, the y values go to -infinity, so the left end is here. And on the right end, as x goes to +infinity, the function values y go to +infinity. So it is up here. So that means that when I graph this one, so I've got these 3 zeros, I'm just going to go right on through them, put my arrows on the ends, and I've got my graph. All right, so here is a practice problem for you to try. You can pause your video here. All right, let's take a look at our graph. So here, estimating the square root of negative 22, we're looking at it being closer to the square root of negative 25, so closer to negative 5, and that would put it at about negative 4.7. Said 4.8, 4.6, okay. All right, but probably 4.7, 4.8 would be better. And then we don't have any multiplicity here. So our end behavior, both of them go to our negative infinity. And so we're looking at it just going right on through them. And then your square root of 5 would be about 2.2. I forgot to mention that one, but all right, let's try another one. Pause your video. All right, let's take a look at the graph here. Now, hopefully on this one, you caught that you actually have 3 different 0 values. You have that one, negative square root of 17. You have the square root of 2. Both of those have multiplicity. And then you have a 0 of 5 that does not. And then we have our end behavior. So our square root of negative, or a negative square root of 17 rather, just a little bit more than negative 4. So you see here it's about negative 4.1. And then the square root of 2 is about 1.4. So you see that one right there. And those have multiplicity. Our end behavior is up on this end and down on that end. And so that creates a relative minimum, turns around, another minimum, turns around and goes right on through that one, like so. All right, so that's going to end this lesson. You can go ahead and do your assignment and have a great day.